Hello and welcome to this video on topic 2. In part 1 here we'll talk about definitions and the role type classification framework that we'll be using throughout this course. Here's a picture of what we'll basically be doing in this course. We'll come back to this and visit it here in a moment. As you can see, the basic idea is to start over here with a population and then to produce some data from that population in a sample, to then do some exploratory data analysis on that sample, and then to use probability to make inferences about those data. So let's take a look at an example. Let's suppose at the end of April 2005 we conduct a poll to try to learn about how US adults feel about the death penalty. In step 1, we'd be looking at how to produce data. In other words, how to find a sample of people to interview about their views. Maybe we get a sample of 1,082 people. In step 2, we would take that collected data and we would run some analysis on it. In this case, let's say we found that 65% of that sample favor the death penalty for persons convicted of murder. And then in steps 3 and 4, using probability and inference, we could use the ideas and the theories from probability to say something like this. We are 95% confident that the percentage of those who favor death penalty in the population is within 3% of what we obtained in the sample. In other words, we are 95% confident that this interval here, from 62% to 68%, that interval will capture or will cover the true proportion of people in the population who favor the death penalty. And we'll explore that much later and in much more detail later in the course. If that's not quite clear yet, it will become more clear later. Here's a picture of what we're talking about. Over here we have in our population a question about what percentage of everyone in the population supports the death penalty. So we take a sample of 1,082 responses. We ask them if they favor or oppose that policy, and we find through data analysis that 65% of that sample, 65% of the 1,082 people, are in favor of the policy. We then move to step 3, and we use probability and therefore then inference to conclude that we are 95% sure that the true population percentage is within 3% of the 65% that we found in our sample. So that's how all those pieces fit together on that picture. In this particular topic, let's look at 2 variables at a time. Most studies are going to actually want to do that. They're going to look at the relationship between 2 variables, as opposed to looking at just 1 variable as we did in the previous topic. Here what we want to do is explore the relationship between those 2 variables using 2 things. 1, a visual display, and 2, a numerical summary. So in this topic we have this basic outline. We'll start with some basic definitions. We'll describe a framework that we will use in order to do this kind of work. And then we'll look at the different cases that we have and that are included in this topic and cover those one at a time. So let's look at an example. Suppose we have this question. Is there a relationship between the ages of your customers and the amount of money they spend in your store? We're going to distinguish between 2 variables, and here's our first definitions. The explanatory variable, the way we define that, is the variable that claims to explain, to predict, or to affect some response. We sometimes call this the independent variable, and we often denote it with the letter X. Our second definition is the response variable. This is the outcome of our study and is sometimes called the dependent variable, and we often denote that with the variable Y. In this particular example, we would say that age is the explanatory variable and net sales, measured in terms of money, is the response variable. The reason for that is that we believe that the age of a particular customer somehow influences the outcome of how much money they spend at the store. And that answers the question that we have up here. So that's our first example of explanatory and response variables. Now, one question you can ask is the choice always clear when you're given two variables? There are studies in which the classification of the variable is not all that clear. This will mainly happen, as you can see here, in cases where both variables are categorical or both variables are quantitative. For example, let's say you have a study that explores the relationship between SAT math scores and SAT verbal scores. In a case like this, any classification of which is the response and which is the explanatory would be fine, just so long as you are consistent throughout your analysis and keeping those two clear. So it's not always 100% clear which should be which, and sometimes you're going to have some flexibility and choices to make. That leads us to what we call the role type classification, which is a helpful model in trying to think about how to analyze situations where you want to explore the relationship between two variables. So given that we have variables of two types, both quantitative or categorical, and that each one could take on one of two roles, either explanatory or response, we then have basically four possibilities for what we call a role type classification. And they are as follows. You could have either a categorical explanatory variable with one of either a quantitative or categorical response variable, or flip that around, you could start with a quantitative explanatory variable and then have either a quantitative or a categorical response variable. So we can actually represent this in a table. It looks like this. Over here, we have our explanatory variables. One that could either be categorical or quantitative. And then over here, we have our response variables, which likewise could be either categorical or quantitative. So here you see the four choices. In this case right here, down in this lower left corner, you see you have a quantitative explanatory variable and a categorical response variable. And then of course you see the other four choices in the other three squares here. When we're confronted with a research question that involves exploring the relationship between two variables, the first and most important step is to determine which of the four cases represents the data structure of the problem. This is going to dictate how we proceed. So our first step should be classifying the two relevant variables according to their role and their type, and then we can determine what statistical tools we should use to analyze them. Let's do some examples. Here's a question. Are the smoking habits of a person related to a person's gender? So in this case, when we talk about smoking habits, we'll keep it simple and we'll either say they do smoke or they don't smoke. So that's how we will treat this particular example. In this case, the explanatory variable is gender and it's categorical. In other words, our gender, we believe, is going to predict the outcome, that is, whether someone smokes or not. So our response variable here is smoking, whether they do or whether they do not. So in this case, our role type classification would be C to C. We're going from a categorical variable, gender, to another categorical variable, smoking, yes or no. So we basically have two possibilities in this categorical variable, male or female, and two possibilities over here in the smoking variable, yes or no. Another example, suppose we ask this question, is there a relationship between the time that a person has practiced driving while having a learner's permit and whether or not this person passed the driving test? So in this case, we believe that the time that a person has practiced is going to influence the outcome, which is whether or not they've passed the driving test. So we believe that time explains the response, whether or not they've passed. So our explanatory variable is time, and that's quantitative. We measure that in perhaps minutes or hours or even days. Our response variable is whether or not they passed, You could think of that as yes or no. So here, our role type classification is Q to C. A quantitative variable, time, predicts our outcome, whether or not the person passes the driving test. In this course, we're going to explore the tools that we use to examine 3 of those 4 cases: categorical to quantitative, categorical, and quantitative to quantitative. The fourth case, quantitative to categorical, such as time and driving test example just given, is covered in a more advanced course. So that wraps up this particular video. It's an introduction to how we're going to approach this particular topic. We'll see you in the next video.